Right now, there's a muscle sitting in your skin with no job left to do. And it still shows up for work every single time you're cold or scared or you hear a song that hits just right. When it fires, the hair on your arms stands up and your skin puckers into tiny bumps. It's as if your body is bracing for something that stopped being a threat hundreds of thousands of years ago. We call this goosebumps. Nobody ever asks the obvious question. If we don't need this reflex anymore, why does it still exist? And why does the symphony trigger the exact same physical response as walking into a freezer? Let's start with what's actually happening under your skin. Every hair on your body, even the fine, almost invisible ones, is attached to a microscopic muscle called the arrector pili. It's a smooth muscle, which means it works automatically. You can't flex it. You can't relax it on command. It answers to the sympathetic nervous system, the same network that controls your fight or flight response. When you get cold or startled or emotionally overwhelmed, your sympathetic nervous system releases a chemical called norepinephrine. That chemical hits the arrector pili muscle and makes it contract. The muscle pulls the hair follicle upright and the skin around it bunches into a small bump. That's the whole mechanism. Scientifically, it's called piloerection. Everywhere else, it's called goosebumps, or in some older texts, cutis anserina, which literally means goose skin. Here's the strange part. This entire system depends on hair, and most of us don't have nearly enough hair left for it to do anything useful. To understand why this reflex exists, you have to go back to a version of us covered in thick body hair. Early human ancestors weren't smooth-skinned. They were as hairy as most other mammals, and that hair was doing real work. When it's cold, hair standing upright traps a thin layer of air close to the skin. That layer of air acts as insulation the same way a puffed-up jacket keeps you warmer than a flat one. For a heavily furred ancestor, piloerection was a genuine survival tool. It created warmth on demand, no clothing required, because clothing didn't exist yet. Then, over hundreds of thousands of years, our ancestors lost most of that body hair. The leading explanation ties it to sweating. Losing fur let early humans cool down more efficiently while running long distances under the African sun. That mattered for hunting and for escaping predators in the heat of the day. Add clothing and shelter into the picture later, and the insulation function of goosebumps became almost pointless. But the muscle stayed, the nerve pathway stayed, the reflex stayed. Evolution doesn't delete old systems just because they've stopped being useful. It just stops needing them. Warmth wasn't the only reason this reflex evolved. There was a second function, and you can still see it clearly in other animals today. Watch a frightened cat and its fur puffs out, making it look bigger and more dangerous than it actually is. A porcupine does the same thing with its quills. This is a threat display, a way of looking larger and more formidable in the split second before a fight or an escape. Human ancestors, back when they were still covered in hair, almost certainly used the same trick. Fear triggers the identical sympathetic nervous system response as cold does. That's why goosebumps show up during a horror movie just as reliably as they do on a winter morning. The muscle doesn't know the difference between a predator and a jump scare. It just knows the nervous system has been triggered, and it does the only thing it knows how to do. For a long time, biologists treated goosebumps as a closed case. Vestigial reflex, no real function left, end of story. Then, in 2020, a research team led by stem cell biologist Yaxie Xu at Harvard published a study in the journal Cell. It reopened the whole question. Using high-resolution electron microscopy, Xu's team looked closely at the arrector pili muscle and found something nobody expected. The muscle isn't just a mechanical lever that yanks a hair upright. It's wired directly into a population of hair follicle stem cells, the cells responsible for growing new hair. The nerve fibers that trigger the muscle to contract don't stop at the muscle. They extend further in and form connections with those stem cells, delivering norepinephrine directly to them. In other words, every time cold or fear makes your hair stand up, your body isn't just bracing for temperature. It's also sending a signal to the stem cells nearby to start regenerating hair. The reflex that looked like a completely useless leftover turns out to be quietly running a second job the whole time. It's one that had gone unnoticed for decades of biology research. It's a rare case of a so-called vestigial trait, turning out to be doing more than anyone assumed. None of this explains the strangest version of the reflex, the one that has nothing to do with temperature or danger. You felt it during a powerful scene in a film or during a song that builds toward a chorus you didn't see coming. Scientists call this frisson, a French word that translates roughly to aesthetic chills. Estimates vary by study, but somewhere around half to two-thirds of people experience frisson with any regularity. Not everyone gets it, and that split isn't random. Research has repeatedly linked frisson to a personality trait called openness to experience, one of the core traits psychologists use to describe personality. People high in this trait tend to be more imaginative, more inclined toward abstract thinking, and more likely to lose themselves in music or art. Brain imaging studies suggest their reward circuitry responds more strongly to the anticipation and payoff structure built into music. That's the moment right before a key change or a vocal note lands. The mechanism is the same one from earlier. Emotion activates the sympathetic nervous system, norepinephrine gets released, and the arrector, pili muscles fire just like they would in the cold or in fear. Your body borrowed an ancient defense system and repurposed it as a response to beauty, the reflex that once kept a hairy ancestor warm or made them look bigger to a predator is the same one that gives you chills today. It happens during the loudest part of your favorite song. The next time you feel that prickle up your arms during a movie, a cold room, or a song that catches you off guard, pay attention. You're not imagining a strange coincidence. You're watching a 500,000-year-old system at work. It was built for a body covered in fur and surrounded by predators, and it's still running quietly in the background of a body that no longer needs it. Evolution didn't switch it off. It just found new reasons to keep it turned on. If you want more stories like this, about the parts of your body still running programs built for a world you don't live in anymore, this channel is exactly where you'll find them. Hit subscribe. It costs nothing, and it's how this kind of storytelling stays alive.